Hello, everybody. Today we're going to be going over the inverse of a 2 by 2 matrix. This is going to be a super quick tutorial because it is very easy to find the inverse of a 2 by 2 matrix. We'll talk about bigger matrices later. So, the inverse of a 2 by 2 matrix, let's say you have matrix A. This is equal to elements A, B, C, and D, i.e. a 2-row, 2-column matrix. The inverse of A, noted as A negative 1, is equal to D. Let's write that a little more clearly. Wow, it erased a lot of things. Didn't quite expect it to do that. D, A, negative C, negative B, times 1 over AD minus BC. Okay, and you might recognize this as the determinant. This is the determinant of A, if you want to think about it like this. So, let's show an example. Let's say we want to find the inverse of this matrix. Let's say 3, 4, 5, 2. Okay. Well, let's say this is equal to L. What is L inverse? So L inverse is going to equal 1 over the determinant. Remember, the determinant is just cross minus cross. So 12 minus 10, which is 2. So our determinant's 2. Times, now all we have to do is we swap around A and D. So our A term is 3, and our D term is 4. So now we have 4 here and 3 here. And then, now we just put negatives on our 5 and 2. So negative 5 and negative 2. Okay. So then, let's just simply multiply by the scalar. So we're going to have simply a 2 by 2 with elements 2, negative 1, negative 5 halves, and 3 halves. So this is going to be your answer for this problem. Okay. Let's try another example, and then I'll also show you a special case. So, let's say we have we have this matrix. I am fumbling right now. Let's say we have this matrix. That is, I don't know how I wrote that, but all right. So we have this matrix. This is going to be 5. I don't know what's going on with my marker. It doesn't work very well. I should be using a pen, but it doesn't let me use a pen. Okay, well, I guess we're gonna have to try to use a different color now. Okay, so let's save the matrix 5, 10, and 7, 7. Okay. Let's say this is matrix matrix C. Our C inverse is just going to equal 1 over the determinant. So remember, that's cross minus cross. So 50 minus 49, which is 1, times, we swap the 5 and the 10, so 10 and 5, and then we add negatives here. But since our scalar is just 1, this portion right here, this matrix right here, 10, negative 7, negative 7, and 5, this is going to be, in fact, our answer for this problem. Now, you may be wondering, what happens if the determinant of this 2 by 2 matrix is equal to 0? Let's give an example. Let's say we want to find the determinant let's say we want to find, not the determinant, sorry, the inverse of a matrix, let's say 4, 3, 2, 6. So if you want to find the inverse of this matrix, we're just going to proceed as usual. So this is going to turn into 1 over the determinant. Remember, it's cross minus cross. So 12 minus 12 is 0. And we have 1 over 0 in the denominator. And from there, we don't even really need to proceed. We could, if we do proceed, we get 3, 4, negative 2, negative 6. But we can't multiply anything by 1 over 0. So what this means is that this matrix is not invertible. So if the determinant is 0 and you get 1 over 0, then the matrix does not have an inverse. All right. Hope everybody liked this video. I will see you all later. Goodbye.